Weeklings, we've noticed that you have difficulties about math topic circle in its part.
So we are here to teach you about that lesson.
But first, let us know what are the parts of the circle.
These are some definitions connected to circle.
Is the straight line that's expanded to the circle.
A straight line joining the end of an arc. It's a segment joining any 2 points on the circle.
Semicircle is an arc measuring the one half, of the circumstances of a circle.
Arc is an arc measured less than semicircle. Major arc is an arc measured greater than semicircle.
Angle. Angle whose vertex at the center of the circle and with 2 radii each sides.
Angle whose vertex is on a circle and whose sides contain chords of the circle.
Let us now proceed to our topic for today.
The sum of the measures of central angles of a circle with no common interiors is 360 degrees.
All measures of arcs and angles are all in degrees.
An arc is a part of a circle.
An arc is like this. It's an arc that measures one half of the circumference of a circle.
This circle have 3 points, point C, point N, and point Z, and have arc dot CN, arc CZ, arc CZN, arc CNZ, and arc NZ. And semicircle is KZ arc. Z.
Major arcs are types of circle are arcs in the circle. It is usually named using the 2 endpoints of the circle.
Major arc measures greater than the semicircle, and it's usually named using the 2 endpoints and another point on the arc.
To get the degree measure of the minor arc, we need to know the measure of the central angle. For example, in this circle, the measure of the central angle is 118. So the measure of the minor arc is also equivalent to 118.
Measure of degree of major arc, we need to subtract the 360 to the measure of the minor arc with the same endpoints. For example, in the same figure, the value of minor arc is 118. So if we subtract the 360 to the 118, the answer is 242.
Semicircle is always 180 degrees.
Formed by 2 adjacent arcs is the sum of the measures of the 2 arcs. The region bounded by an arc of the circle and the 2 radii to the endpoints of the arc.
Area of the sector, we need to get the ratio of measure of the arc divided by 360.
On this figure that have shaded part, that is sector of a circle. The radius of circle C is 10 cm and measurement of arc AB is equal to 60. What is the area of sector ACB?
Go!
To get the measure, we need to substitute the measure of the arc into the 60 degrees Celsius. So 60 divided by 360 equals to 1/6. For B, area is equals to pi r squared. Area equals to pi. We need to substitute r, or the radius, for 10 centimeters. So 10 centimeters squared equals to 100 centimeters squared pi. For letter C, we need to multiply the sector and the area. So 1/6 times 100 centimeters squared pi is equivalent to 100/6 centimeters squared pi. We need to get the lowest term, so we need to divide it by 2. So 2 divided by 100 is 50 and 2 divided by 6 is 3. So the answer for the area of the sector ACB is 50 centimeter squared over 3 pi. We can see that there is only piece of shaded region, which is we call segment of a circle. To get the value of the segment of the circle, we need to get also the sector of the circle, which is PTQ. equals
Penis.
to, if the value of arc PQ is 90, we need to divide it by 360, which can be also equivalent to 1/4. So 1/4 times 5 centimeter, which is our radii, is equals to, which is equals to 1/4 times 25 centimeter squared pi. If we so if we multiply it by 1/4, then the value will become 25 over 4 pi centimeters squared. To get the triangle of PTQ is equals to 1/2 base times height. So 1/2 times 5 centimeter and 5 centimeter will become 1/2 times 25 centimeter will become 25 over 2 centimeters. To get the main value for the segment, the sector of PTQ minus triangle PTQ. So 25 over 4 pi cm squared minus 25 over 2 cm squared will be approximately 7.135 centimeter. Yan yun.
That's it. We hope you understand the circles and its parts.
Now get the hell out of our ship.